Good day, Matrix. I'm sure, like me, you're starting to feels a bit like when your good old lockdown days, with all this online work. I'm sorry about it. That's just the way it is. AP is hectic. As I say, normally there's a 3-day workshop in the holidays, but I'd rather do it like this. And for many ways, I think it's better because full-day workshops, you lose focus, nothing really sinks in. It is important to keep up to date, though, guys. Otherwise, it's going to be a stress just before your exam. So, the next last little bit of techniques of integration is going to be integration by parts. Okay, you actually won't need anything. Right. So let's just share the screen. Share screen. Okay. So with integration by parts, okay, well, the proof for it comes from the product rule. So let's have a look. So the product rule says the derivative of f of x g of x is equal to, we know this well, this is the one part times the other plus f of x times g dash x. Right. So all we do to get the parts formula is integrate everything. So we have the integral of the derivative of f of x g of x with respect to x is equal to, so integrate this bit. Okay, integrate this bit, and to become the integral of f dash x g of x. We actually don't normally write the dx in. Okay, plus the integral of f of x g dash of x. So that's that bit over there. So we just find the integral of each bit, and then the derivative and the integral of a derivative, they're opposite functions, so they essentially cancel each other out. So you're left with f of x g of x. Can't do anything with that. I'm just going to leave it as is equal to the integral of f dash x g of x. Let's see if I put the dx in the image. I don't think we're normally write it with we do actually. So dx, that should have been dx. Okay. So it's equal to the integral of f dash x gx dx, which is that one over there, plus the integral of f of x g dash x with respect to x. Okay. And then if we isolate it, okay, we end up with the integral. Let's see which order that it is. If we move this, get this on its own, the pink bit on its own, we'll have the integral of f of x g dash x with respect to x, okay, is equal to, so I've kept that on the right hand side, so it'll be f of x g of x, the yellow bit, minus f of x g of x, so sorry, I've skipped out a step, which often is more complicated. The pink bit here is on its own, so that was on the right hand side, it will be equal to the yellow bit minus the green bit, so minus f dash of x g of x dx. Okay, and that is the proof. This is the formula which we're given, and it's what we call integration by parts. Okay, so the integral of f of x times g dash of x, so g is not related to f at all. Integral of f of x g dash x is equal to f of x times g of x minus the integral of f dash x g of x with respect to x. So that's for integration by parts. That is on your info sheet. Okay. Now, how do we use this? Well, I use this really if I can get, so I'm going to do an example now. The key bit really is that if the bits are different, this integral here in green, okay, is made up of f dash x, the derivative of the one bit. To get to g of x, you start with g dash x, and that'll be the integral. G of x will be the integral of g dash x. So the key idea is parts is only really going to be work if this green bit has to end up being easier to integrate than this bit over here. There's no point in doing integration by parts if that integral is more complicated than that integral. Okay, so usually the trick is if f of x is something like x, okay, and I differentiate that, the derivative of x is 1, okay, and then it becomes a lot easier. Okay, so, but that's the key idea. There's no point. This must be easier to integrate this integral over here than that one over there. Right, so let's do our first integration by parts. You're guaranteed to get one in every exam from now on. So how do you spot it? Well, substitution is not going to help us here. If u is equal to x, du dx, okay, it's not going to make life much a bit easier. We're not going to be able to get rid of that. Okay, so substitution is not going to work. None of the other tricks are going to work because no formulas for that. Okay, this x, this is a very common type of question, where the x times something, or 5x, or 3x. And the key idea then is this. Because the derivative of x is 1, which is going to make that integral easier to use. So, what I'm going to do is I want to differentiate the x. So I'm going to say let f of x be equal to x, and therefore f dashed x is equal to 1. Okay. Then I'm going to say, then this other part, I'm going to call g dashed of x. So let's g dashed of x is equal to sine x, because the formula says we must have f of x times something we call g dashed of x, which means g of x is equal to the integral of g dashed of x, which is equal to, what I have to differentiate to get to sine, I have to differentiate negative cos x, because the derivative of cos is negative sine x. So g of x, okay, will be equal to negative cos x, g dash x is sine x, and if f of x is x, f dash of x is 1. So if I write the formula down, I've got the integral of f of x, g dashed x with respect to x is equal to f of x, g of x, minus, swap them around, the integral, okay, of f dashed x, must I swap them around compared to the original, okay, and instead of g dashed x, you're going to have g of x. So that's the formula we're going to use. So in other words, in this case, therefore, the integral of x sine x with respect to x, well, I'm letting f of x be equal to x, right? So it's going to be equal to f of x is still x. Now I'm going here, so there f of x was x. G dashed of x is sine x. In this formula, I've got f of x. F of x is going to be is x. G of x is over here. So it's x times negative cos x. That's your g of x. X times negative cos x. And the key thing now is minus the integral. Well, f dashed of x is 1. So it's minus 1 times g of x. Okay, and g of x we know is negative cos x. And this makes life a lot easier because that is now 1 instead of an x. Okay, and that's probably the most common way in which we use this. So I've got that pattern over there. So this becomes equal to, if I make this prettier, it becomes negative x cos x. If I take out the negative, it becomes plus the integral of cos x with respect to x. Alice will be ashamed of my integral sign there, no doubt, which is equal to negative x cos x, or what I have to differentiate to get to cos, plus sine x plus a constant. And there, ladies and gents, is your first sum by doing integration by parts. Okay, right, get that done. And let's try the next one. Right, so the next one you're going to do is going to be the integral of 3x, sec 3x with respect to x. Well, always your first step is just get rid of the 3. 3 times the integral of x over sec 3x with respect to x. The substitution is not going to help us here. There's no fancy tricks I can use. the one trick I can remember is that 1 over cos x is equal to sec x, and likewise 1 over sec x is equal to cos x, right? So I can rewrite this as being 3 times the integral of x, or 1 over sec 3x, okay, is going to be the same thing as cos 3x. So it's going to be x cos 3x. I can rewrite it like that, which is a much easier form to work with. So now, no substitution is going to help us. Focus your mind, write down the formula. Okay, well, we'll get back to the formula, but we know now we need the 1 bit. I'll write the formula here. So we're going to have the integral of f of x g dashed x with respect to x is equal to f of x times g of x minus the integral of f dashed x g of x with respect to x. Okay, so if I differentiate x, okay, if I let that be equal to f of x, the derivative of x is just 1, which makes that integral a lot easier. Okay, I want you to try give it a go yourself. Right, press pause, try your first integration by parts on your own. Right, so the key is let f of x be equal to x, therefore f dashed x is equal to 1. Then the other bit must be the derivative bit, so let g dashed x equal to cos 3x, and therefore g of x, what I have to differentiate to get to cos 3x? Well, it's sine 3x, but if I differentiate that, I'll get cos 3x times 3, and I want to get rid of the 3, so it will be sine 3x over 3. Okay, so I've got f of x, f dashed x, f of x here, all the yellow bits that go together, and they're all the green bits that go together, g dashed x, g of x, g dashed x, g of x, g dashed x. Right, so now it's a question of just popping those in. So this becomes, therefore, the integral of f of x, g of x is going to be careful. I've got 3 times it, right? So 3 times the integral of f of x, g dashed of x is going to be equal to 3 times, so we're looking for 3x cos 3x with respect to x is going to be equal to, okay, f of x, which is x, g of x, which is sine 3x over 3, minus the integral f dashed of x is 1, g of x is equal to sine 3x over 3, but this whole thing should be multiplied by 3. So minus 1, okay, g of x, sorry, was sine 3x over 3. Right, so there's your g of x, there's your g of x, okay, there's your g dashed of x, there's your f of x, f of x, f dashed of x. Right, and that integral is not going to be too bad to handle because we've got rid of the x. So this is all going to be integral equal to, well, the 3's, okay, I'm not going to leave the 3 outside for now. So I'm going to get x sine 3x over 3. Here I'm going to take out that third at the bottom, so it'll become minus a third, the integral of sine 3x with respect to x. Okay, so I get 3 x sine 3x over 3 minus a third. What I have to differentiate to get to sine 3x? I have to differentiate negative cos 3x, because the derivative of cos 3x is negative sine 3x. So I get negative cos 3x, then I have to compensate for that by dividing by 3, so the chain rule. Okay, so it's negative cos 3x over 3, and we can shove the constant in now if I want, plus 3. If I distribute the 3 now into that, okay, it'll become x sine 3x. That 3 and that 3 will cancel, and I'll be left with plus. I've still got that 3 over there, cos 3x over 3, or you can write it as a third cos 3x, same thing, plus a constant. So there, guys, is your answer. Okay, very nice stuff. Remember, if I stop any careless, make any careless mistakes, please WhatsApp me, Okay, and I will do push-ups and buy you a chocolate. Right, so there is an integration by parts. Very neat, very lovely. Okay, right. Now, these come from your textbook, but you don't need your textbook. I've written the question down. Okay, we're doing exercise 10, page 283, A3 and 5, and B1 and 2. So, A3, you've got the integral of sine x cos x with respect to x. Now, just to show you the two ways I could do something like this. Okay, well, if I do it by parts, well, it's a little strange one by parts because at first it doesn't look like it's going to help you. But let's just write, so let's say I let f of x be equal to sine x. Okay, then f dashed x is equal to cos x, right? So I've got the sine x is f of x, f dashed x is cos x. And if I say let g, then the other bit must then be g dashed of x is equal to cos x. So g of x will be the integral of that, which is sine x. I probably wouldn't have done this by parts. It wouldn't have been my first thing. I'll show you what I would have done now. So if I use integration by parts, I've got the integral of f of x g dashed x is equal to f of x times g of x minus the integral of f dashed x, sorry, you got this way around? Yeah, minus f dashed x times g of x with respect to x. So here's all the f of x bits and the g dashed of x bits. Okay, so in other words, the integral of sine x cos x is equal to f of x, which is sine x, times g of x, which is sine x, okay, minus the integral f dashed of x is cos x, g of x is sine x with respect to x. Now, how does that help us? Because we're back to where I started. But the thing is, that and that are exactly the same thing. They're both the integral of sine x cos x. And if I move that across, doesn't matter which order that goes in, I've got therefore 2 times one integral plus another integral makes 2 of the same. One of that's just a value plus another value. So I get 2 lots of integral sine x cos x with respect to x, okay, is equal to sine squared x plus a constant. Okay, so in other words, I would maybe not put the constant in there yet. It doesn't make any difference at all, I promise you. If you wrote it as c over 2, it would be absolutely fine. Okay, so in other words, divide by 2, and we get the integral of sine x cos x with respect to x is equal to a half sine squared x plus a constant. And there is your answer. Okay, I wouldn't have tried to do that by parts first. Remember, if you've got sine and cos in the same angle, we know that sine 2x is equal to 2 sine x cos x. In other words, a half sine 2x is equal to sine x cos x. Okay, equal to sine x cos x, right? So in other words, the integral of sine x cos x with respect to x is equal to the integral of a half sine 2x. Take out the half. Okay, half sine 2x with respect to x, which is equal to, well, what I have to differentiate to get to sine 2x, okay, the integral of sine 2x is a half. I have to have negative cos 2x divided by 2 plus a constant. And you're going to have negative a quarter cos 2x plus a constant. Now you're all going to be squealing like little rabbits and saying, but that's wrong, that's wrong. Okay, it's not the same as that. Okay, the thing is, integrals actually, believe it or not, don't have to look the same because of this constant of differentiation. Okay, that c and that c will balance out. But I think we can just quickly show this. They're both right. I promise you they're both right. Well, if I took negative a quarter cos 2x Well, cos 2x is the same thing as 1 minus, cos 2x is 1 minus 2 sine squared x, eh? Minus 2 sine squared x, double angle formula, okay? Cos 2x is 2 cos squared 1, yeah, that's right. And if I simplify that, I get negative a quarter plus a half sine squared x. And then you're going to say, but it's still not the same. And that's fine because of this constant of integration. So that constant of integration, this c, let's call that c dashed, will be equal to that c minus a quarter. Okay, but the key thing is that the half of the variable bits are the same. Really, it doesn't matter if there's a difference in the constant. Okay, all right, that's just to show you integration can be done in different ways. Okay, get that down. Right, now remember, so now you've got the integral of ln x, which we haven't, you don't expect it to know that formula, but here's quite a nice little way in which you can show what it is. So they gave you a hint. They said rewrite it as the integral of 1 times ln x with respect to x. So we can do this by parts. Okay. And the easiest way to do it by parts is, what do we know that the derivative of ln x is equal to? Well, the derivative of ln x is 1 over x. Okay. So how does that help us? Well, I want to that bit over here, I want to differentiate the ln x. So I'm going to say, right, I'm going to be using this formula, the integral of f of x g dashed x with respect to x is equal to f of x g of x minus the integral of f dashed x g of x with respect to x. So I want to differentiate ln x. So I'm going to let that be equal to f of x, and then that'll be f dashed of x. So if I let f of x be equal to ln x, okay, f dashed x is equal to 1 over x, which means the other bit, in this case is 1, must be equal to g dashed of x, which if I integrate that, I get g of x is equal to the integral of 1, which is x. Right, go try to do it by yourself. Okay, press pause, give it a go. So I get the integral of ln x of 1 times ln x with respect to x, where that's f of x, is going to be equal to f of x, which is ln x, okay, times g of x, all the g dash bits, okay, and g of x is equal to x, ln x times x, minus the integral, well, f dash x is 1 over x, and g of x is x, and voila, that makes life very lovely. So I end up with x ln x, okay, minus the integral of 1 with respect to x. So in other words, it's x ln x minus x, plus a constant. And that, ladies and germs, is the integral of ln x. So, past you'll be expected to know that off by heart. The integral of ln x is equal to x ln x minus x plus c, and the proof comes from integration by parts. How lovely is that? Alrighty, put that down. Last one, okay, is question B from your textbook. So it's the integral of x, 1 plus 2x with respect to x. First of all, they said, let's do this by substitution. Okay. Well, if I do this by substitution, remember, always try to let that whole thing underneath the square or that under a power be equal to u. So I'll say, right, let u is equal to 1 plus 2x. So therefore, du dx is equal to 2. Okay, we've got to get rid of the dx, remember, in substitution. So I'm going to have du is equal to 2 dx So therefore, du over 2 is equal to dx. So dx, now I could replace with du over 2. I can replace 1 plus 2x with u. The problem is this x over here, but it's not a big problem because I know that 1 plus 2x is equal to u. So isolate the x, I get 2x is equal to u minus 1. So x is equal to u over 2 minus a half. Okay, so there's x. So if I go back to the sum and re-express it all in terms of u, I get the integral of u over 2 minus a half, that's that bit over there, times the square root of 1 plus 2x, which is root u. Okay, that's that bit over there. Okay, and then the dx is du over 2, which is this bit here. It looks ugly, but it's not really that bad. So I can take out this 2 from here, so it'll be a half, and I can take out with all times. So I'm taking out, that could become a half, times that half is a quarter. So I can take out a quarter, and I'm left with the integral of u minus 1 times root u with respect to u, which I can times it out because it becomes a quarter. Okay, the integral, sorry, of root u is u to the half times u minus 1 with respect to u, which is going to be a quarter. The integral, you multiply powers, add the exponents. A half plus 1 is 3 over 2. U to the 3 over 2 minus u to the half with respect to u, which is going to be a quarter. 3 over 2 plus 1 is 5 over 2. So it's going to be a quarter u to the 5 over 2 divided by 5 over 2 times by 2 over 5 minus u, add 1, u to the 3 over 2 divided by 3 over 2, so suddenly it's timesing by 2 over 3 plus a constant, sure, it's been longer than I thought, which is going to be equal to a quarter times 2, u is what? U is 1 plus 2x, so 1 plus 2x to the 5 over 2 divided by 5 minus 2 over 3, u is 1 plus 2x to the 3 over 2 plus a constant. So there's your final answer. It should all be in a big bracket. Constant go outside the bracket. So your final answer is a quarter times 2 over 5, 1 plus 2x to the 5 over 2 minus 2 over 3, 1 plus 2x to the 3 over 2 plus a constant. I'm not going to look at the memo. Got to back myself. Make an error, you know the deal. So, it looks right to me. Okay, as I say, let me know if I've made some careless mistake. You can issue a head slap. That same sum, though, could be done by parts. And in fact, it probably might be a little bit easier by parts. A warning, the answers might look completely different. Okay, they're both right. Okay, so the integral of x 1 plus 2x, well, if I let f of x, I'll do this by parts. Oops, this might become a mission as well. I'm going to go to another page. So the integral of x 1 plus 2x with respect to x. Okay, root, what's it? Integral of x root 1 plus 2x with respect to x. Okay, yep, that's right. And I've got to do that by parts. Okay, it's always quite exciting when you choose not to look at the memo. So, which is always what I do actually, otherwise I get bored. So, what we're going to let be equal to what? Well, let's think about this. I'm going to go with generally the principle that works is to let f of x is equal to x, because then what happens is f dash of x is 1, which generally makes our life easier. But now, then g of x, g dash of x is equal to the square root of 1 plus 2x. Okay, so g of x is going to be the integral of 1 plus 2x to the half with respect to x. And we can do this by inspection, so it's going to become 1 plus 2x to the 3 over 2. Okay, now if I differentiate that, I'm going to get 3 over 2 at the bottom, which is divided by 3 over 2, so I'm going to have to be timesing by 2 over 3. That's got to do with this bit over here. Okay, so the derivative, that'll cancel out, and I'll be left with 1 plus 2x to the half, but then I've got to times it by 2. So because of the chain rule, I'm going to have to divide that extra bit by 2. Those 2's will cancel, and I'm going to be left with a third 1 plus 2x to the 3 over 2. Okay, right. So this is g of x. So g of x, g dashed of x is the square root of 1 plus 2x. G of x then is a third 1 plus 2x to the 3 over 2. Okay, and f of x is x and f dashed x is 1. So now if I go the integral of x, let's write the formula. The integral of f of x, g dashed x with respect to x is equal to f of x, g of x, minus the integral of f dashed of x, g of x with respect to x. In other words, the integral of x root 1 plus 2x with respect to x. So f of x is that, f of x is that. I'm going to make it, my green's running out. G dashed of x, g of x, that's g of x. Okay, so I'm going to have f of x times g of x. So f of x is x. Here's my f of x. Here's my g. Okay, f of x is x. G of x is a third 1 plus 2x to the 3 over 2. Okay, so there's f, there's g of x, minus the integral, or f dash of x is just 1, and g of x is a third 1 plus 2x to the 3 over 2. Okay, right, there's f, there's g. So I end up with this whole thing being equal to x over 3, 1 plus 2x to the 3 over 2. Okay, and take out the third, minus a third times the integral of 1 plus 2x to the 3 over 2 with respect to x. So it's equal to x over 3, 1 plus 2x to the 3 over 2 minus a third. Well, the integral of 1 plus 2x to the 3 over 2 is going to be 1 plus 2x, add 1 is 5 over 2. Divide by 5 over 2 is the same thing, but it's timesing by 2 over 5. So that's 5 over 2 goes with that 2 over 5 there. Okay, then times the derivative of the inside function. You've got a constant which is 2. You've got to compensate for that 2. So you times by 2. And now we can put in my constant. So I end up with x over 3, 1 plus 2x to the 3 over 2. Those 2's will cancel, so I'll be left with minus 1 over 15. And I'm going to have 1 plus 2x to the 5 over 2. Okay, plus a constant. Whew, some pretty grown-up sums there. Okay, so there is that same sum by integration by parts. Okay, and I can pretty much guarantee you the answer doesn't look the same. That is the weird part of integration. Okay, but they can always be proved to be the same, assuming I made careless mistakes. What did we get over here? 1 plus 2x to the 5 over 2, as long as we've got the right powers. And 1 plus 2x to the 3 over 2, so the powers are all right. Okay, so I think we're all good. Okay. Okay. As I say, let me know if I made any careless mistakes. I'll check them out and I'll get back to you if I have. All right, guys. So all I want you to do now, after that long lesson, okay, again, if you at some point try these. Exercise 10A, 1 and 4. I didn't give you the whole lot. And C, 1 and 2. Okay, just do those two. A1 and 4, C1 and 2. Remember those on Teams. Okay, guys. Arrivederci. Take care. Goodbye.